Data science is an interdisciplinary field that involves the use of scientific methods, algorithms, processes, and systems to extract insights and knowledge from structured and unstructured data. It combines techniques from statistics, mathematics, computer science, domain knowledge, and data engineering to analyze and interpret data. The primary goal of data science is to uncover meaningful patterns, make data-driven decisions, and generate predictions or recommendations. Key components of data science include data collection, gathering, acquiring, and sourcing data from various data streams, databases, and external sources. Data cleaning and preprocessing, preparing and cleaning data to ensure it's accurate, complete, and in a suitable format for analysis. This may involve handling missing values, outliers, and other data quality issues. Exploratory data analysis, EDA. Visualizing and summarizing data to understand its characteristics, identify trends, correlations, and outliers. Statistical analysis. Applying statistical methods to gain insights and make inferences from the data. This can include hypothesis testing, regression analysis, and more. Machine learning. Developing and training machine learning models to predict future outcomes, classify data, and automate decision-making processes. Machine learning is a crucial component of data science, allowing for predictive and prescriptive analytics. Data visualization. Creating visual representations of data to communicate insights effectively. Data visualization tools and techniques help present complex information in a comprehensible way. Big data technologies. Data science often deals with large datasets. Tools and technologies like Hadoop, Spark, and NoSQL databases are used for handling and processing big data. Domain knowledge. Understanding the domain or industry-specific context is essential for interpreting data correctly and making informed recommendations. Data engineering. Designing and building data pipelines, data warehouses, and data storage solutions to support data science activities. Ethics and privacy. Data scientists must consider ethical implications and privacy concerns when working with sensitive data, ensuring that data usage complies with legal and ethical standards. Data science is applied in various fields and industries, including finance, healthcare, marketing, e-commerce, social media, and many others. It can be used for a wide range of purposes, such as predictive maintenance, fraud detection, recommendation systems, sentiment analysis, and more. Data scientists often work with a variety of tools and programming languages, including Python and R, as well as libraries like NumPy, Pandas, scikit-learn, and TensorFlow. They use these tools to explore data, build and deploy models, and generate actionable insights that drive decision-making and innovation. Example of data science. Data science is a broad field with a wide range of applications. Here's an example of a data science project in the context of predicting housing prices using a dataset. Problem: predicting housing prices. Dataset. A dataset containing information about various houses, including their features such as size, number of bedrooms, location, and price. Steps in a data science project. Data collection. Obtain a dataset of housing information. This data could come from various sources, such as real estate websites, public databases, or surveys. Data preprocessing. Handle missing data. If there are missing values in the dataset, you might choose to impute or remove them. Data cleaning. Ensure that data is consistent and free from errors. Feature engineering. Create new features or transform existing ones to make the dataset more informative. For example, you might calculate the price per square foot or extract the year in which the house was built from the date. Exploratory data analysis, EDA. Explore the dataset to understand its characteristics. This could involve creating visualizations to show the distribution of housing prices, the relationship between variables, and potential outliers. Calculating summary statistics to describe the data. Data splitting. Divide the dataset into training and testing sets. The training set is used to build the model, while the testing set is used to evaluate its performance. Feature selection. Choose relevant features, variables, for the model. Some features may be more important for predicting housing prices than others.
Model building. Select a machine learning algorithm. In this case, you might choose regression models like linear regression or more advanced ones like random forests or gradient boosting. Train the model on the training data. Model evaluation.
Use the testing set to evaluate the model's performance. Common evaluation metrics for regression tasks include mean absolute error, MAA, mean squared error, MSE, and root mean squared error, RMSE.
Model tuning.
Adjust hyperparameters and model settings to improve performance.
You can use techniques like cross-validation to find the best hyperparameters. Deployment.
Once you are satisfied with the model's performance, you can deploy it as part of a web application, mobile app, or any other platform where users can input house features, and the model can predict prices.
Monitoring.
Continuously monitor the model's performance and retrain it periodically as new data becomes available.
This is just one example of a data science project.
Data science can be applied to various domains and problems, from predicting customer churn in e-commerce to disease classification in healthcare, and much more. The key is to use data to gain insights, make predictions, and drive informed decision-making.
Is data science a coding?
Yes,
coding is an integral part of data science.
Data science involves using programming and scripting to work with data, build models, and create data-driven solutions.
Here's how coding is used in data science. Data collection.
Data scientists often write code to collect data from various sources, such as web scraping, database queries, or APIs.
Data preprocessing. Cleaning and preparing data for analysis requires coding. This includes handling missing values, transforming data, and converting data types. Data analysis and exploration.
Data scientists use code to explore and analyze data, creating visualizations and summary statistics to understand the dataset's characteristics.
Feature engineering. Creating new features or transforming existing ones to improve model performance often involves coding. Model building.
Data scientists write code to select machine learning algorithms, train models on data, and tune hyperparameters for optimal performance.
Model evaluation.
Code is used to assess model performance, including calculating metrics like accuracy, precision, recall, and F1 score for classification problems or metrics like mean absolute error, MAE, and root mean squared error, RMSE, for regression problems.
Deployment. If the model is intended for use in applications or websites, data scientists write code to deploy the model and create interfaces for users to interact with it. Automation. In some cases, data science projects involve automating decision-making processes using code, such as building recommendation systems or fraud detection algorithms. Monitoring and maintenance.
After deployment, data scientists continue to write code to monitor the model's performance, retrain it with new data, and make necessary updates or improvements. The choice of programming languages can vary, but Python and R are two of the most popular languages in data science due to their extensive libraries and community support. Data scientists may also use tools and libraries like NumPy, Pandas, Scikit-learn, TensorFlow, PyTorch, and Jupyter Notebooks to facilitate data analysis and model development. In summary, coding is a fundamental skill in data science, and data scientists rely on programming to work with data and build predictive models that provide valuable insights and solutions.